the SpaceX thing, or who's that?
I get them all confused. I think it's NASA.
Yeah, I heard about it. Some kind of new mission or something. Can't wait to look at the CGI.
Okay, can I do my images, please?
Yeah, please go ahead.
All right, thank you. So this is just the original image, right?
Right.
I'll be honest. The part on the left with the really tall tower, I don't know what's going. I don't know what that is, but that wasn't part of the thing that I was trying to explain. So I've just kind of sliced it off because just ignore it, and it helped me think. So in this one, oh, hold on.
I'm going to post something I can't explain.
Image 3. So there's 2 red lines, right?
Mm-hmm.
The top red line is what I believe shows the curve of the Earth. There is a little bit of atmospheric distortion there, but it's not enough that it would change the overall shape of this curve, right?
Right.
The bottom curve, the bottom red line, also curves, which also shows the curve of the Earth.
Does it?
Wait,
or is it an optical illusion?
Just
he's standing on. It's maybe a different argument. He wants to restate. You're restating what you said, right? So let's erase everything he said before, and he's going to redo this again. All right, go ahead. Right.
So this is last image.
Mm-hmm.
I've circled a little area. That area there is refracted so much that it's created like a weird, I don't know, it's like curved back on itself.
Okay.
I don't know the exact science of why it's made that exact shape.
Okay.
But that point is refracted to the point where it's not usable as a reference, like to help show the shape of anything because it's so distorted, right? So ignoring that section in the circle, the 2 other lines is what I think shows the curve because they would be distorted to such a small degree that it wouldn't change that general shape, that general curve. Does that make sense?
Yeah, I get what you're saying, but what I want to see, because you need to test it more vigorously, I'd like to see someone shoot a laser through it and see what happens.
That would be cool.
Then you get more data.
But it's an Bryce, going back on what you're saying here, disregarding everything you said previously, right? Let's just start afresh. How about that?
All right.
So you're saying that, let me pull up your image. Yeah, thank you very much, Endless. Putting your image up there, we're looking at refraction, curvature. We're looking at curvature, refraction, curvature. Because we have curvature at the top and curvature at the bottom and refraction at the bottom, right?
There's refraction everywhere, but the only spot where it makes any change to anything useful would be that little circle.
You're putting a wrench in the machine, man, right now.
No, I didn't. That's exactly what I said the first time. You're trying to change what I said.
Everywhere?
There's refraction everywhere, but it's to such a small degree that it doesn't change the shape to a notable amount. The only spot where it does that is that little circle that I've made.
Yeah, but doesn't refraction change the idea that you can tell where curvature is? Because it'll make the image distorted if it's everywhere. I thought it was only a lot at the bottom, a little bit at the top, but we're discarding that. Now we're saying it's everywhere.
No, I've always said it's everywhere. I've just said lots at the bottom, little at the top. There's also the poles that are towards closer to the camera, they will also be distorted to some degree. But like I said, it's not enough that you can tell by looking at a still image. If you were to have this as a time lapse, you'd be able to see little wiggles.
Right. So once again,
and a still image, it doesn't change it.
Listen, I'm not condescending, right? Don't take it this way. But you're agreeing with us, and we would say exactly what you're saying. The only difference is you're assuming that curvature can be involved in this somehow. But we would say that what you're thinking is curvature is just, like you said, all over refraction. So there isn't any possible means that the idea that you're assuming is just the fact that you have a biased view on it. But just like you said, refraction everywhere, lot at the bottom, little at the top. That's fine with us. It's an optical phenomena. But you're stating that it's curvature, and it's not. It's just an optical phenomena. So once again, you're agreeing with us. There's no difference.
I disagree that refraction could create that illusion.
You're restating it in a way to kind of support a point, but like I said, you're just assuming. But because of the fact you understand reality like we do, then you would say it's an optical phenomenon taking place, that therefore it could be curvature and it might not be curvature. So you're just rolling the dice, hoping that it could be landing on curvature. But it's an optical phenomena. It's an optical phenomena overall, so you can't really know.
What is the it in it is an optical phenomena?
Well, didn't you just say refraction?
No, but what is the it? What is being distorted here? Other than in that little circle. I'm saying everything except for that little circle looks
all
normal.
over distorted. You said it's all over distorted. But I'm agreeing with you. Yeah.
All right. So this isn't something we can resolve, because I'm saying
we can't resolve
everything in the image isn't distorted to a degree that you can tell, but you're saying it is. That's not something that we can really prove. So that's not really something we can continue with.
If it's noticeable, then yeah, it's happening, right?
But if it's noticeable,
then it's not noticeable now.
That's what I'm saying. So, okay. I get where the confusion's come from. I'm
not repeating what you're saying. You're saying all over refraction. We know that it's happening, so it's noticeable, right? Now you're saying it's not noticeable.
It's noticeable in the tiny circle that I drew. I'm not saying it's noticeable everywhere. This is okay. I think I know where the confusion is. Okay, I know where the confusion is.
Everywhere, right?
But not to a degree that we can see.
So it's happening everywhere.
But not to a degree that we can see, so you can effectively ignore it.
Yeah, I mean,
no, it's not noticeable. I'm literally saying it is not noticeable except for that little circle.
Then how do we notice that it's happening everywhere if it's not noticeable?
What refraction does.
You said refraction is there, but it's not noticeable. How do you know that it's happening if it's not noticeable?
Because refraction just happens when light travels through air. Anytime. Everything you see is refracted in some way.
Okay.
But it's so tiny, it's such a small amount that you do not notice. The only time you notice is when it's extreme, like in the tiny circle that I drew.
Bryce, that's a contradiction. If something's happening and you don't notice it, then you won't know it's happening. That's pretty simple, right?
We don't know that refraction exists because we see it. We know that refraction exists because we know how light works.
You just finished saying that at the bottom it's heavy, at the top it's light. So we do notice it.
When I say at the bottom, I think I need to clarify. When I said at the bottom, I meant at the bottom where they're really far away in that little circle. And then at the top, above that little circle, those power lines out there, at the top, those are barely distorted, not to a degree we can see.
Then we can't say it's happening all over. You can't say that because you don't notice it.
All right, fine. We'll say it's not happening all over. It's only happening in that little circle.
I'm just stating, Bryce, that it comes to the point where you're going to have to say that you can't notice it. Then all right,
I agree. We can't notice it. We can't notice it except for in that little circle.
All right. So that's what we're going with.
But wait, what about all the other photos? Like, you just can't base your whole thing off this one photo. Like, what about all the other photos that kind of